What's up, scholars? Today we're talking about reasoning with properties from algebra. This is going to be our introduction to proofs, which are amazing. You're going to love them. They will stretch your brain. You're going to be awesome. You're really going to love these proofs. They're very intuitive. You'll know what you're doing pretty quickly. It's going to be great. To prove something, though, we have to have some basic bits of understanding that we all agree on, which in these proofs, when we're proving things, proving statements, algebraic statements, the things that we all agree on that we can use to prove stuff are going to be our algebraic properties of equality. We've got a bunch of them. Addition, subtraction, multiplication, division, reflexive, symmetric, transitive, those will be new, substitution, and distributive. So all the ones that I said that I didn't say were new are things you know intuitively in your heart. So the addition property says, if I have some statement where the left side equals the right side, I've got A equals B. Whatever A is equal to B. I can add something to both sides of the equation, and it's still true. Then A plus C equals B plus C. So I start out with a true statement, the left side equals the right side. I can add something to both sides, and it's still true. So the addition property is relating to adding things to both sides. Who knew? I knew, and now you knew. Subtraction property is going to be very similar. If the left side of an equation equals the right side of an equation, we can subtract something on both sides, and it will still be true. Then A minus C will equal B minus C. That's why it's called a subtraction property. We're subtracting. The multiplication property, what do you think we're going to do? Yeah, we're going to multiply. We got to start out with this. If the left side of something, of an equation equals the right side, then it's totally fine if we multiply both sides by the same number. A times C equals B times C. How about that division property? Oh yeah, we're going to do some dividing. If A equals B, then A divided by C will equal B divided by C. We can divide both sides by the same number. All right, addition, subtraction, multiplication, and division. I want to skip down to the substitution property. A substitution property. We'll start it the same way. If A equals B, so the left side equals the right side, then I can substitute B in for A in any equation. If they're equal to each other, I could put B where A was, and it would still be true because they're equal to each other. So B can be substituted in for A. You can plug B in for A in any equation. They're equal to each other. So that means if I see 5A, I could actually say that's the same thing as 5B. If A and B are equal to each other, you can plug B in anywhere you want. You see A. Cool. The distributive property, if, let's say we have C times the quantity A plus B, if I have that situation, then you can distribute and multiply C times both parts of these, C times A and C times B. Actually, I feel like I'm saying it kind of weird. Distributed property just means we're using distributed property. But if you have this situation, then you also have A times C. I'm going to write it in alphabetical order because that makes my brain feel better, which is the same as C times A. So C times A is the same as A times C. And C times B is the same as B times C. All right. Distributed property means you can use the distributed property. Great. Now this reflexive, symmetric, and transitive properties. These are our properties that you likely haven't used yet in Algebra in such a way that you recognize them. So, the reflexive property says something equals itself. Something equals itself. A equals A. Something equals itself. That's the reflexive property. The symmetric property says if I have two terms like A plus B, that'll be the same as B plus A. I can put those in the opposite order. Right? I can add those in the opposite order. Or even more simply, if I have A equals B, I can write that in the opposite way. Then B will equal A. A equals B, then B equals A. This is the one I really want you to remember. A equals B, then B equals A. That's the symmetric property. We can flip the left side and the right side of the equation. And since they're equal to each other, they will still be equal to each other. The transitive property is my favorite. It says if A equals B and B equals C, if you have something equal to something else, and that something else is equal to a third something, then that original equals the third one. Then A equals C. You don't need the middleman B anymore. A equals B and B equals C, then A actually equals C. It's like you skip right over it. Because they're both equal to the same thing. If they're equal to the same thing, they must be equal to each other. I'm just going to put a star next to it because it's the coolest. It is the coolest. All right, let's do some examples using our properties. Actually, I'm going to keep this down here so we can look at the properties while we use them. Great. Ba-da-ba-da-ba! Okay, this is called a two-column proof. It's got statements on the left, reasons on the right. It is in two columns. That's why it's called a two-column proof. And we always start our proofs with what we are given. We have to be given somewhere to start. So the first reason we always have is given. We are going to use the given of 5x minus 18 equals 3x plus 12. That's what we're given. We're going to solve this equation using the reasons that we just talked about, these algebraic properties of equality. Cool. So what would you do to solve this equation first? A couple different choices here. I would add 18 to both sides. I would add 18 to both sides. Which property says I'm allowed to add something to both sides of the equation and it's still true? Oh, right, the addition property. So we're going to use the addition property. Addition property. Add 18 to both sides. If we add 18 to both sides, those 18s cancel. And we just have 5x now equals 3x. What's 18 plus 12? 30. Great. Now let's get the x's together by subtracting 3x on both sides. Which property says we're allowed to subtract something on both sides of an equals sign? You're correct. It's the subtraction property. Subtraction property. What do we get when we do that? We get 2x equals 30. And then we need to divide by 2. Which property says we're allowed to divide on each side of the equal sign? It's the division property. We divide by 2 on both sides. We're using the division property. We get x equals 15. That's our final answer. We had a reason for everything that we did. We proved it, right, with these properties that we've all agreed are true. So you can't argue with me. We agree that all these things are true. And I only use these true things to do stuff to this statement, so you can't argue with me. That's what proofs are. They are unarguable, logical, organized thought processes. A thing of absolute beauty. All right. Check out number 2. We've got 55z minus 3 times quantity 9z plus 12 equals negative 54. What's our first reason on? It's given. It's given. What will we do first to solve this problem? I would distribute that 3. That negative 3, actually. Distribute that negative 3. What says I'm allowed to do that? The distributive property. So when we distribute that negative 3, we get 55z minus 3 times 9z is 27z. And negative 3 times 12 is negative 36 equals negative 64. All right, you're going to continue this on using the properties. Oh, I'll do the next step with you. It says simplify. It's giving us a hint here. The suggested next activity is simplifying. What could we simplify from step 2? Yeah, we could put the z's together. Let's do that. What is 55 minus 27? It is, in fact, 28. 28z minus 36 equals negative 64. All right, you're going to do the next 2 steps because your big, giant brains are just ready for it. Ready for it. Fabulous. Okay. Let's go on over to the backside. Giving a child an adult dose of medicine can be dangerous. If an adult dose is 500 milligrams, a child's dose, C, can be determined from the age A in years using this equation. A equals 6... Try that again. A equals 6 over 125C minus 1. Solve the formula for C and write a reason for each step. Okay, what are we given? We are given that A equals 6 over 125C minus 1. We're trying to solve the formula for C. What does that mean? We're going to get C by itself. Get C by itself. Right now, A is by itself. We're going to get C by itself. All right, who's hanging out with the C right now that I can get rid of real quick? That 1. Let's add 1 to both sides. Why are we allowed to add things to both sides? The addition property. Cool. So we get a plus 1 equals 6 over 125c. I have a fraction being multiplied by c. How do I get rid of its denominator? Let's multiply by its denominator. Let's multiply both sides times its denominator so that these guys cancel out. So we are multiplying when we multiply by the denominator, we got something on the top, something on the bottom, that cancels out. So now we just have 6c on that side. Multiply by this denominator, we get 25a plus 125. We're so close. C is almost by itself. We just need to divide by 6 on both sides using the division property. So we get 125a plus 125 over 6 equals c. Great job. Nicely done. Let's use the results to find the child's dosage for an 8-year-old child. So we have the child's dose is 125 a plus 125 over 6 That's it, right? Use the results to find the child's dose for an 8-year-old child. What did A stand for? That was our age. So what are we going to put in for A? 8, because it's an 8-year-old kid. So C equals 125 times 8 plus 125, all divided by 6. Well, I'm going to need some help because I don't know what 125 times 8 is. Let's go find our handy-dandy calculator. This special baby's been in my life for a long time. Yep. 125 times 8 is 1,000. 1,000 plus 125 all divided by 6. So 1,000 plus 125 is 1,125 divided by 6. So a child's dose is going to be 187.5. What's our units here? Looks like milligrams. Kid's going to need 187.5 milligrams according to this calculation. Great. All right. Question number 4. The formula to convert Fahrenheit to Celsius is C equals 5/9 times F minus 32. This looks like a candidate for my scholars to do. You know what the given is. It's that dude. You're going to solve the formula for F, get F by itself, and write a reason for each step, and then figure out what Fahrenheit temperature is equivalent to 20 Celsius. Awesome. Awesome, awesome. You guys are doing great. We got one more page of notes to go. Here's where the fun stuff really starts to get going. The properties we used in Algebra, the ones I said were brand new, can also be used in geometry. Great. So the reflexive property of segment length, what does reflexive mean? Sum was equal to itself. So that'll be true for a segment. The length of segment AB will equal the length of segment AB. It's going to equal itself. That'll be true for an angle too. The measure of angle A will equal the measure of angle A. So a quick note about notation. When we are talking about segment length, we do not put the segment bar on top. No segment bar on top. When we talk about angle measures, we need to make sure we put the M in front. Put M in front of angle. Otherwise, they mean different things. Okay. The symmetric property said if A equaled B, then B equals A. So the symmetric property for segment length is going to say if segment AB is equal to segment DE, then we can flip that around. Then segment DE is equal to segment AB. Change the order, still true. The angle version is going to say if the measure of angle A is equal to the measure of angle B, then I can flip that around and it's still true. The measure of angle B is still equal to the measure of angle A. Flip sides of the equal sign doesn't change anything. It's still true. And the transitive property, this beautiful beast of an animal, if we have segment AB and it is the same length, its measure is the same as segment CD, and that segment CD is equal to the measure of segment EF, then the segment AB is actually equal to EF. We can skip right over C. So cool. Angle measure version. If the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, then the measure of angle A is going to equal the measure of angle C. You can skip right over angle B. Skippity skip, skip, skip. Skip, skip. All right. Let's use our newfound properties of segment length and angle measures to do some examples. You guys are doing wonderful. Hang in there. Okay. Example number 1. An AC is equal to BD. We're going to verify or prove that segment AB is equal to segment CD. Write out a reason for each step. We know the first reason is always the thing that we're given. What are we given? It says in the figure below, AC is equal to BD. AC is equal to BD. Okay. Let's figure out a plan for this proof. We know, based off of this, that the distance from A to C is equal to the distance from B to D. We're trying to show that these chunks here are equal to each other. Well, we also know that this long segment, A to C, is made up of, let me just cover it up. A to C is made up of that little guy, AB, plus BC. We know that segment BD is made up of that same BC plus CD. So, since AC equals AB plus BC, and BD equals BC plus CD, and we know those are equal to each other, we could set AB plus BC equal to BC plus CD, and subtract off the part that have the same, and we'd be left over with those guys. So that's what we're going to do. That's what we're going to do. All right. A lot of these proofs, when we first start, you're going to get some hints on where to go, because these are definitely challenging. You got to kind of learn the way that we organize these two-column proofs. So it gives us a hint, reflexive property. Reflexive property meant something is equal to itself. We talked about in our plan, we're going to be using the fact that this BD segment is the same in both AC and BD. So we can say that that BC is equal to itself. The reason we're doing that is we're going to subtract that thing that's the same off of both sides, that AC and BC. All right, we start with this, AC equals BD. We're going to subtract off BC from both sides. If we are subtracting something on both sides, that must mean we're using the subtraction property. Okay. Gives us another hint. AB plus BC equals AC. Well, we talked about that in our plan. AB plus BC equals the whole segment AC. It also says BC plus CD equals BD. We talked about that in our plan too. BC plus CD equals BD. Why is that true? Why do two segments that are next to each other add up to a bigger segment? The segment addition postulate. The segment addition postulate. Postulate. It's true for both of them. Two segments add up to a third segment. Two segments add up to a third segment. That's the segment addition postulate. All right, Rooney. Says the substitution property. What did that mean? That meant if something was equal, just going to remind us, if A equals B, then I could plug B in for anywhere in an equation where I had A already. So we started out with AC equaling BD. That's kind of like A equals B. So anywhere that I see one or the other, I can plug that in. AC equals BD. We also have down here AB plus BC equals AC. So I can take this entire expression and plug it in for AC here. They're equal to each other. This equals AC. So instead of this AC, I can plug that guy in there. And similarly, BD equals BC plus CD. Higher expression, since it equals BD, and plug it in for that BD here. And we have AB plus BC now equals BC plus CD. So we did a double substitution. Now we're so close. We're trying to get to AB equals CD. We have AB plus BC equals BC plus CD. So if we subtract off that BC, then we're left with what we want. So let's use that subtraction property. All right. Give yourselves a hand. You just made it through your first formal proof. That's amazing. That's so good. Wonderful. All right, let's do one more together. One more together. It's going to be really similar to what we just did. Quite very similar. All right. Measure of angle ABC. The measure of angle ABC is equal to the measure of DBE. Okay, so these two little angles are equal to each other. We're trying to show that ABD is equal to CBE and write a reason for each step. We're given that the measure of angle ABC is equal to the measure of angle DBE. Great. Great, great, great. Gives us a little hint here. We're going to use the addition property of equality. What do you think we might want to add to both of those? I'm trying to look at ABD and CBE. ABD, what does it have? Let me cover that up. What does ABD have that ABC does not? It's got ABC, that angle. And then if we added the angle next to it, That'd give us angle ABD. Okay. Similarly, CBE. CBE is this big angle, E. You see my B? Good. CBE is this big angle. If we added that same middle guy to it, we'd get that CBE. So CBE is the angle that we're given, this little one, plus this middle angle. So let's add CBD to both. The measure of angle ABC plus the measure of angle CBD equals measure of angle CBD plus the measure of angle DBE. We added something to both sides. Why is the measure of angle ABD equal to the measure of ABC plus CBD? ABC plus CBD equals ABD. That's the angle addition postulate. You add two angles that are next to each other. You get the third angle. That's what it says. We have the same reason, so there must be another angle addition postulate we're looking at. What's the other angle we're trying to talk about? CBE. Well, CBE is made of CBD plus DBE. So the measure of angle CBE is equal to the measure of angle CBD plus the measure of angle DBE. It's like alphabet soup up in here. So many letters. So many letters. All right. Our last step. We had measure of angle ABC plus CBD equals CBD plus DBE. I see that same expression here. So that means I can plug the other thing in for there because they're equal. So where I see ABC plus CBD, I can actually just put ABD. And I see that the measure of CBD plus measure of angle DBE, that's right here, so I can actually plug that guy in right there. We could do another double substitution to say that the measure of angle ABD equals the measure of angle CBE. Awesome. So good. Things to remember on both of these proofs. The segment addition postulate, that will pop up all the time. Two segments that are next to each other can be added to make a third segment. And same deal, the angle addition postulate will pop up all the time. Two angles that are next to each other can add to be a third angle. All right, give yourselves a hand. Maybe go reward yourself with your favorite snack or something. You did a great job. Thanks for hanging in there. Keep up the good work, scholars. I love you. I'll see you next time.